Analytical geometry. We are now looking at question number 4, which is over here as shown above. And the question reads, find the equation of a line with an angle of inclination of 30 degrees that passes through the point 0 and 9, and do not use a calculator. Now there's a reason they ask you not to use a calculator, and we'll look at that shortly. Okay, so my pen is responding. Now, there's some terminology here that we need to get through. And what is that terminology? Well, it says angle of inclination, right? I want to spend a little bit of time on angle of inclination. So what exactly is the angle of inclination? Well, if I have a line, and let's say I have an axis like that, and there's my coordinate system, there's my axes. Oops. Mama. There we go. And now I want to take that line. Let's say that make the line red. There's my line. Now you can see that's a straight line. And let's get the pen back. Let's make that red. Now this angle theta from there to there, that's your angle of inclination. That is your angle of inclination. So I'm just going to write that there, and I'm going to say that theta over here is the angle of inclination. Ooh. Angle of inclination, right? Theta is the angle of inclination. So what do we define the angle of inclination to be? The angle of inclination is the angle that a line makes with the positive x-axis. It is the angle that the line makes with the positive x-axis, right? Okay. So if I had to have another line, and let's make a green line over here. There's a green line. Okay, then that line's angle of inclination in a green pen over there is from there to there. There we go. It's a little bit bright, but that will be, let's call it alpha, that will be that one's angle of inclination. Right. Okay, so let's see. Let's clear the page and let's read this over here. Find the equation of a line with an angle of inclination of 30 degrees and that passes through that point. Now, there's one formula I didn't speak of at the beginning, but it relates to gradient, and it's also amongst the well-known formulae, is that tan of the angle of inclination is equal to the gradient of that line. Okay, is equal to the gradient of that line. So if I take a line and I say, well, let's say there's a line that passes through 0 and 9, and that line looks like this. That line looks like so. Right, there we go, that's my axes. I'm going to make the line red, the line that we use, 0 on the x and 9 on the y, which, let's say it's something like that. Okay, that's passes through there, and I know that it has an angle of inclination of 30 degrees. Now, using this property that tan theta is equal to the angle of inclination, the tan of the angle of inclination is equal to the gradient of that line, we can actually find what the gradient of this line is. Now, tan of 30 is equal to a special angle which is actually root 3 over 3, right? Or 1 over root 3. And you can prove that, you can show that. Do you know how to show that? Let's quickly get an aside, because tan 30 is equal to sine 30 over cos 30, right? Now sine 30, do you know what that is? Sine 30 is actually a half, and cos 30 is equal to root 3 over 2. And then similarly, you're going to get a half multiplied by 2 over root 3, then you're going to get 1 over root 3. And this is the same as saying root 3 over 3. Or you can just say you know your special angles, and you know that tan 30 is equal to root 3 over 3. Right? So let's make it 1 over root 3. Okay. Now if I want to find the equation of the line, what I need to do is I need to say, well, okay, I need to use the point. So I say y is equal to mx plus c, where m is the gradient, and we know that the gradient of this line is just tan of the angle of inclination, which has been given. And that's going to be y, and the y value is going to be 9, multiplied by 1 over root 3, multiplied by x, which is 0. That's the point that we're using, and then we can find that the value of c is equal to 9. Therefore, c is equal to 9. Now this gives us the equation of the line because now we have c and we've got the slope, so we can say that y is equal to 1 over 3, or rather 1 over root 3 multiplied by x plus 9. And there we go. That's actually question number 4 in our revision series. So in this lesson we dealt with, again, the equation of a line and also angle of inclination.